Punish him. Kill the guy now. You have to come. What?
What is this?
Good day, sir.
You are watching Jackie Pan in my house.
No, it's King Kong, sir.
King Kong. You've never heard of ACTV before in your life? ACTV is very educative, informative, and there are football sport there. There is entertainment. There are a lot of things you can even attend lectures here. All you know is watch all those nonsense artists and do nonsense, or you watch nonsense on TV. Last night you almost came in bed with your fist.
It's not me, sir.
And you wake up every morning, the bed will be so rough, like you'll be fighting kung fu in your dream. That's the reason why you have F's in your courses, like especially made for you.
I have it last semester.
We by pounds on you. Very stupid though. Yeah, change that section to ACTV right now. And oh God, the baby wants to have the first born. Stupid boy.
Good day to you from wherever you're watching us. I hope you're keeping safe too. Just before the lockdown, as you know from our course outline, there are 3 aspects to the outline. The first one is calculus, then we have complex numbers, and the numerical analysis. Just before the lockdown, we're able to conclude all teachings on the aspect of calculus. And this afternoon, I'm here to go into complex numbers. And I hope as you follow, you will grab and get a good understanding. Now, when you say complex numbers, it deals with the symbol. It deals with a symbol. But then I have to tell us how come about complex numbers. At secondary school level and even at earlier parts of our admission, we looked at, we have encountered quadratic equations at some point or the other. Suppose we have y to be 5x squared minus 6x plus 5. And we need to solve this quadratic equation. There are different methods. We could use factorization, completing the squares, graphical method, and then the formula method. For this, the formula method will work. And what is the formula method? X is given as minus b plus or minus square root of b squared minus 4ac all over 2a. Now we go back to the original equation given. A will be 5, that's the coefficient of x squared. B will be minus 6, and C is 5. If we apply this formula, you're going to have that x is equal to root minus 64. And that presents a problem. We have square roots for only positive numbers and not negative numbers. So because of that, we need to address the negative here so that we can arrive at a solution to the root of minus 64. So that bettered the concept of representing I to be equal to minus root 1. Now, if that is the case, then from our problem, x becomes root 64i. But before we get to that stage, if I is root minus 1, then I squared will give you, I squared will give us minus 1 by squaring both sides. So this becomes 64i squared. Then at the end of the day, when we take the square root, this gives us 8i, because the square root of 64 is 8, and that of I squared is I. So if we go back to the problem, we're going to have that x is equal to 6 plus 8i all over 10, or 6 minus 8i all over 10. So by the time we simplify further, we are going to get the solution to the problem. So in handling quadratic equations, when negatives come under the square root sign, that was how we came about dealing with complex numbers. So how are complex numbers representation? They are usually given as z is equal to a plus bi. A is usually referred to as the real part, and your b is referred to what? The imaginary part of the complex numbers. Just as any ordinary number, we can add, we can also subtract and multiply complex numbers. But before we go to the addition and subtraction of complex numbers, I would like us to see how we can handle powers of I. Powers of I. Let's take it from the beginning. We said I is the same thing as root minus 1. And when we square it, I squared is minus 1. And then how about I cubed? I raised to power 3 is the same thing as I squared multiplied by what? Multiplied by I. And we said this is what? Minus 1, then multiplied by what? Root minus 1. So we have multiplied by root minus 1, which will give you minus I, because we have said that this is what? Then we can go on as many powers as possible. Supposing we have I raised to power 4, that will give you I squared multiplied by I squared, which is the same thing as minus 1 multiplied by what? Minus 1, and that will give us what? Plus 1 or 1. So that is important, because anytime we need to add or subtract complex numbers for ease of operation in the eyes. Now let's quickly take a simple example on addition, and let's look at addition and subtraction. We take the first example. Suppose we have 4 plus 5i plus 3 minus 2i. What do we do? You are going to add the real part with the real part and the imaginary part with the imaginary part. So this boils down to 4 plus 3 plus 5i plus and minus will give us minus 2i. And this is equal to 7 plus 3i. And that's the answer. Suppose we have up to 3 complex numbers and we need to add them up. We are going to take the same approach. Suppose we have 5 plus 7i plus 3 minus 4i minus 6 minus 3i. Like I said before, we take the real parts together and then the imaginary parts together. So what do we have? 4 plus 3 plus and minus will give us minus 6, then plus 7i minus 4i minus minus will give us plus 3i. So this gives us 8 minus 2. 8 minus 6 will give us 2. This will give us 10 minus 4 will give us 6i. And that's our answer. So like we said, complex numbers can be added and they can also be subtracted as shown. Apart from adding and subtracting complex numbers, we can also multiply complex numbers. So let's look at the multiplication. If we have 3 plus 4i and we want to multiply it with 2 plus 5i, you must be very familiar with the quadratic expansions, the one we did at secondary school SS1, even GSS3. So this can be brought down to, we use this to multiply that, 2 plus 5i, then we take the complex part, plus 4i, 2 plus 5i. Can now expand 6, 15i. 2 times 3 will give us 6. 3 times 5 will give us 15i plus 8i. Then this will give us plus 20i squared. This is where the powers of I come in. If we look at what we have here, we said I squared is the same thing as what? Minus 1. So I come back here and I replace. Of course, this gives me 6 plus 23i plus 20 multiplied by what? Minus 1. So this gives us 6 plus 23i minus 20. We have 6 minus 20 minus 14i minus 14 plus 23i. So each time you want to, if you have up to 3 complex numbers, 4 complex numbers, you can still follow the same procedure. Take 2 at a time, and then you multiply through and get whatever you're looking for. Then there's what we also call conjugates. Conjugates of a complex number. Now, if you have, for example, if we have a plus bi, then the conjugate becomes a minus bi. Now, I'm going to show us what will happen when you multiply 2 conjugates together. For instance, if we have 5 plus 8i multiplied by 5 minus 8i. Obviously, the 2 are conjugates of each other. And like I said before, we follow the previous procedure, plus 8i into 5 minus 8i. Let's expand and see what we have. 25 minus 40i plus 40i. This will give us minus 64i squared. Of course, minus 40 plus 40 will give us 0. So we're going to have 25 minus 64. And like we said before, I squared is the same thing as what? Minus 1. Minus multiplied by minus will give you plus. So that gives us what? 89. Because you're going to have 25 plus 64. Which will give you 89. Now, like we can add complex numbers, subtract complex numbers, multiply complex numbers. And then in the case of dividing complex numbers, we are familiar with sorts. We can operate it with the same way we rationalize sorts using the conjugates. Complex numbers can also be graphed. So what do you do when we want to graph complex numbers? It's very easy. Graphing on 2D, you have 2 things. We have the x-axis and the y-axis. So what do? There are 2 reference points. And every complex number has 2 values. We said it has the real part and then the imaginary part. So how do you graph it? You put the real part of the imaginary number will be along the x-axis, and then the imaginary part will be along the y-axis. Now suppose I give us two complex numbers and we want to graph it. Say Z1, and we call it 2 plus 3i, and then we have Z2, let's say minus 3 plus 2i. Now, along the x-axis, okay, we're having negative numbers. So I'll do this. 1, 2, minus 1, minus 2, and then minus 3. Then for the y-axis, if you take note, we only have positive values. So you're going to have 1, this will be I, 2i, then 3i. Of course, this is your y-axis, and this is your x-axis. Now we want to graph Z1. Along the x-axis, we're going to mark 2. And along the y-axis, it's going to be 3. This is 2, and this is 3i. So we draw it this way, and we call this Z1. Then the other one, we have minus 3. This is minus 3, and then 2i. This is my 2i. I mark the point. We call this Z2. This is what we call an Argand diagram. An Argand diagram, which is usually used to graph your complex numbers. And complex numbers are just like vectors. They have magnitude, they have direction. And from those graphs, we can also get the resultant of 2 or more vectors using the graphical method. Now, there are basically 3 ways in which we can represent complex numbers. The first one I talked is just the ordinary one, the very general one, where I said z is equal to a plus bi. Then we have the polar form. The polar form. That's polar form of representing the complex numbers. So suppose we have this diagram. We mark this angle as theta. This is P, this is O, and then I call this R, and I call this A, and this is B. Of course, this is a right-angled triangle. Now, by Pythagoras theorem, we know that R squared will be equal to A squared plus B squared, which means that if we want to get the magnitude of R, it's going to be the square root of A squared plus B squared. I keep that. Then at secondary school level, we talked about SOHCAHTOA. When we say sine is opposite over hypotenuse, an acronym, we have SO, CA, and then TOA. Now we want to look at if we want to look at tangent, for example, if you want to look at tan theta, tan is opposite over adjacent. Now if we want to see our tan theta, this will be our opposite, and this will be our adjacent, and it's going to be what? B all over A. So if we want to get theta, theta will be arctan B all over what? All over A. Again, for us to get A, how do we get A? This will be what? Adjacent over hypotenuse. We give us what? Sine theta. So if you have sine theta, that will be what? Opposite over hypotenuse. Opposite over hypotenuse. That's B all over R, which means that your It means that B is equal to what? R sine theta. I'll keep that. Then again, how about cos theta? Adjacent over hypotenuse. Then my cos theta will be, which is A all over R, which means that my A is what? R cosine theta. So let's go back there. What did we say was a complex number? We said Z is equal to A plus BI. If you come back here, that's in relation to A and B. Like I showed us on the Gantt diagram, your real value, which is A, is along the x-axis, and your imaginary is along the y-axis, which is B. Now, if we want to relate this, then what will that be? Z now will be, what is our A? A is what? R cos theta. And what is our B? B is what? R sine theta. Then we have I. What do we have in common here? R. So we have cos theta I plus I sine theta. So that's the polar representation of what? Of our complex number. And at any point, if we need to get the angle so formed by the complex number, then we can use what? Tan theta. And when we take arc tan B over A, then we get what? The value of the angle so desired. Let's quickly take an example. Now we want to express that complex number. Z is equal to 4 plus 3i in polar form. So what's the first thing? We get our R. And we're told that R is what? A squared plus B squared. And that will be 4 squared plus what? 3 squared. Of course, this gives us 16, 9, root 25. And we're going to have what? 5. Our R is 5. So how else do we get the angle? Then the theta. What's our theta? Theta is equal to what? Arc tan. Arc tan what? B over A. And what's our B? Our B is what? B is 3. A is what? 4. So you have arc tan 0.75. And if you check from your tables, you're going to have 36 degrees and then 52 minutes. Then, in polar form, what do we do? What did we say is a representation in polar form? Z is R into cos theta plus I sine theta. So, what is our R, which we have estimated here? That will be 5. Then cos. What's our theta? 36 degrees, 52 minutes, plus I sine 36 degrees, and then 52 minutes. So I've represented it in degree and then minutes. So much for polar representation. We can also have exponential representation of complex numbers. Exponential representation of complex numbers. This can be gotten from induction. Now, all right. From our series expansion, anytime we have exponential x, it is the same thing as 1 plus x squared over 2 plus x cubed over 3 factorial plus x raised to power 4 over 4 factorial. And it continues. Also, when you have sine x, the series expansion is x minus x cubed over 3 factorial plus x raised to power 5 over 5 factorial plus minus x raised to power 7 over 7 factorial. Then again, the series expansion of cos x is 1 minus x squared over 2 plus x raised to power 4 over 4 factorial minus x raised to power 6 all over 6 factorial plus, and then it continues. We are going to do something. We are going to replace x with, we're going to replace the x in exponential x with theta I. And when we replace that with theta I, what do we have? Exponential theta I will be equal to 1 plus theta I plus theta I all squared all over 2 factorial plus theta I raised to power 3 over 3 factorial. And it continues like that. By the time you simplify, taking into cognizance the powers of I, you're going to arrive at 1 minus theta squared over 2 factorial plus theta raised to power 4 over 4 factorial dash 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 plus theta minus theta cubed over 3 factorial plus theta raised to power 5 over 5 factorial dash dash dash. You close it. Now if you look at this with this identity given up, you will discover that what happens? Exponential theta I is equal to cos theta plus I sine theta plus I sine theta. There's an I outside here. So successfully, we have been able to give the 3 representations of the complex number. I think we've done so much for today. We've done so much. We looked at what complex numbers are and how we came about complex numbers. We saw how we could add, subtract, and multiply complex numbers. We discussed conjugates, and then we looked at the various representations of a complex number, polar form, exponential form, and we also looked at the Gantt diagram. I hope I made some impact and you're able to learn something. But I guess if you go over it again and with a little practice, you will have a better understanding. Thank you very much.
Okay.
Finish him. Kill the guy now. You have to come.
What? What is this?
Good day, sir.
You are watching Jackie Pan in my house.
No, it's King Kong, sir.
King Kong. You've never heard of ACTV before in your life? ACTV is very educative, informative, and there are football sport there. There is entertainment. There are a lot of things you can do. You can even attend lectures here. All you know is watch all those nonsense artists and do nonsense, or you watch nonsense on TV. Last night you almost came in bed with your fist.
It's not me, sir.
And you wake up every morning, the bed will be so rough, like you'll be fighting kung fu in your dream. That's the reason why you have F's in your courses, like especially made for you.
I have you last semester.
We eat by pounds on you. Very stupid. We are changing that section to ACTV right now. And oh God, the baby wants to have the first born. Stupid boy.
Our Lord is not shy.